This is the example video for graphing linear inequalities. So this should be the sheet right in front of you. I will start with number 1. Okay, so first off, y is greater than x plus 2. So taking a look at this, it's already in the form we like, which is slope-intercept form. Okay, my sign is greater than, so I know my line will be dotted. Okay, so I can just go ahead and graph it. So I will start at my y-intercept, which is positive 2. And my slope is my coefficient in front of my x, which there appears to be no number, which means it's 1. So I'll go up 1 to the right 1. Up 1 to the right 1. And my slope is positive, so there's no negative sign, which means that this line should be going up from left to right. So as I'm making my points here, that appears to be the case. All good news. So now I'll make my line. Put arrows on it. But as of right now, I have a solid line. So I'll make it dotted. Make sure it's very clear whether it is a solid line or a dotted line. Okay? So now I need to figure out where to shade. So I will plug in a test point. And my test point will be 0, 0. Because in my opinion, that's the easiest to deal with. Okay, so test point's right here. And when I plug in 0 for x and for y, I get 0 is greater than 0 plus 2. So I just took 0 for x, plugged it in for x over here. Took 0 for y, plugged it in for y over here. So when I simplify, I get 0 is greater than 2. But 0 is not greater than 2. This is false. So instead of shading on the side that 0, 0 is on, okay, because my test point was on this side, since it's false, I'll shade on the opposite side. And that'll work. Okay, pause the video if you need more time. I'm on to number 2. Okay, y is greater than or equal to negative 5. So just looking at my sign right off the bat, I know this is solid. Okay, and I remember that whenever I have y equals just a number, or y with an inequality sign and a number, okay, I remember that is going to be a horizontal line. Okay, so I'll go to negative 5. On the y-axis. And this means all points on this line, or all y coordinates are going to be negative 5. So I've got my line that looks like that. And it is solid, so I don't need to erase and make this dotted. Okay? So all this is asking for our test point, this is just asking us to find where all the y coordinates are greater than or equal to negative 5. Okay, so I know if I go down my y-axis this way, that's where all my points will be less than negative 5. So I want to shade up in this direction because this is where all my y coordinates are greater than or equal to negative 5. And again, you don't have to shade every single box. Just make it very clear which side of the line you are shading. Okay, pause if you need more time. Number 3. So number 3, we need to manipulate a little bit because this is in standard form because the x and y are on the same side. So I'll rewrite it over here so I have a little more room. So 2x plus 3y is greater than 9. So I'll subtract 2x from both sides to get the y by itself. When I do that, 2x minus 2x cancels. So I am left with 3y is greater than negative 2x plus 9. So next step to get the y by itself, I'll divide by 3. Divide everything by 3. So those 3's cancel. So I am left with y is greater than negative 2/3 times x plus 3. Okay? And I remain with my greater than sign here. Okay? I keep my greater than sign. If I had to divide by a negative 3 here, then I would have flipped my sign. But because I divided by a positive number on this side, my sign will stay the same. Okay? So I can graph this line. I'll start at my y-intercept, which is positive 3. My rise is negative 2, so I'll go down 2 and to the right 3. Down 2 and to the right 3. Or I can go up 2 and to the left 3. Okay? So I'll make my line going through all these points. That looks about right. I'll add my arrows. Okay, a couple more things to do. First off, I need to take a look at my sign. I have a greater than sign, so I know my line will be dotted automatically. So let's make it dotted. Okay, and now I need to shade. So I'll pick 0, 0 as my test point again. And I'll plug it in to my original equation. Okay, so I'm not going to plug it in here. That way I'm not dealing with this sign flip, because if I forget to flip the sign, if I had to, then that will mess up all of my shading. So I'm going to plug it into my original equation. So we have 2 times 0 plus 3 times 0 is greater than 9. So 2 times 0 is 0, 3 times 0 is 0, and 9 will remain the same. So 0 plus 0 is 0, so I get 0 is greater than 9. That is and always will be false. So instead of shading on the side that 0, 0 is on, because it was false, I need to shade to the opposite side of the line. Just like that. Okay, pause the video if you need more time. Okay, x is less than negative 1. So if I think back, I remember that whenever I have x equals a number, or x some inequality sign, a number, I know it's going to be a vertical line. So I'll go to negative 1 on the x-axis, and I know I will have a vertical line that runs through that point, because that's just saying our x-coordinate will always be negative 1. So I'll add some arrows. My sign is less than, so I know it'll be a dotted line, because this actual line is excluded. Okay, so now for shading. To simplify this, I am looking for the side of the line where all our x-coordinates will be less than negative 1. So greater than would be to this side, less than would be to this side. So I'll shade this side of my line. And that's good enough for me. Okay, I'm on to number 5. All right, number 5. Here we have an equation or an inequality, rather, in point-slope form. So I'll try to get it in slope-intercept form. So first off, I need to get rid of those parentheses. So I'll multiply this x and this -2 by -3. So that'll leave me with y plus 9 is greater than -3x plus 6, because -3 times -2 is a positive 6. So now I will subtract 9 from both sides. And when I do that, 9 minus 9 cancels. So rewrite my new equation over here. I end up getting y is greater than -3x, and 6 minus 9 is a -3. So it's in slope-intercept form now, so I'll start at -3 on the y-axis. And my slope is -3, which is the same thing as -3 over 1. So I'll go down 3 into the right one, down 3 into the right one. Or I can go up 3 into the left one, up 3 to the left one. And keep doing that until I run out of space. So now I'm ready to make my line. Put my arrows, because it does go from -infinity to infinity. I'll take a look at my sign, which is greater than, so I know this line will be dotted. So let me get my eraser. This is a very important step. You might think that having a dotted line versus a solid line is a minor difference, but it actually tells us some valuable information. So please, please, please don't forget that. So now I need to shade. So I'll pick a test point. I'll pick 0, 0 again. And I'll plug it into my original equation. So we get 0 plus 9 is greater than -3 times 0 minus 2. Okay? On the left side, 0 plus 9 is 9. Okay, now I'll take care of what's in parentheses. So 0 minus 2 is -2. And I'm multiplying that by -3. So on the left side, it's already simplified. My sign stays as greater than, and -3 times -2 is a positive 6. So here I have 9 is greater than 6, which is true. So since 0, 0 was on this side of the line, and I plugged it in and it was true, I will shade the side that 0, 0 is on. Okay, almost done. On to the last problem. Pause if you need more time. All right. Last one. So in point slope form still, taking a look at my sign, I know this will be a solid line because it is less than or equal to. So what I'll do first is take care of my parentheses. So when I do that, I'm left with y minus 3 is less than or equal to 4 times x minus 1. So I'll distribute. So I get y minus 3 is less than or equal to 4x minus 4. I can add 3 to both sides. -3 plus 3 cancels. So we have y is less than or equal to 4x, and negative 4 plus 3 is negative 1. So I will start at my y-intercept, which is negative 1. And my slope is 4, which is the same as 4 over 1. So I will go up 4 to the right 1. Up 4 to the right 1. Or I could go down 4 and to the left 1. Down 4 and to the left 1. So I can make my line now. Extend it in both directions and add arrows to show that it goes from negative infinity to infinity. And for my point, I will still pick 0, 0, which is just to the left of this line. And I will plug it in to my original equation. So when I do that, I have 0 minus 3 is less than or equal to 4 times 0 minus 1. So 0 minus 3 on the left side is negative 3. Sign stays less than or equal to. I'll take care of what's in parentheses, so 0 minus 1 is negative 1. And I've still got this 4 hanging around out front. So when I simplify this, I get negative 3 is less than or equal to negative 4. Okay, and negative 3 is not less than or equal to negative 4, so this is false. Which means instead of shading on the left side of this line where 0, 0 is, I'll shade to the right side. All right. At this time, I recommend that you move on to the practice for graphing linear inequalities.